This is the video for lesson 9.3 where we're solving quadratic equations using square roots. A handy technique if the equation is given to you in a form that makes this easy to use. So I'm looking in your book. This is example 1. This is on page, just follow along with me, 498, where it gave you an equation to solve, and it was 3x squared minus 27 equals 0. Isolate the square term that you're solving for, so 3x squared equals 27. I'm solving for x squared, so I'm dividing both sides by 3, and then taking the square root of both sides. Square root of x squared is x, and the square root of 9 is plus or minus 3. So x is positive 3, or x is negative 3. For the b example, x squared minus 10 equals negative 10. Again, I'm isolating that x squared term. So in this case, you're going to add 10 to both sides, finding out that x squared is equal to 0, and the square root of both sides, the square root of 0, remember, is 0, so x equals 0. Only one root in this case. And the last one in that example that they gave you was negative 5x squared plus 11 equals 16. I'm isolating that x squared term again, so negative 5x squared equals 5. This one I'm solving for x squared, negative 1. Can we take the square root of a negative number? No, we cannot. And that means there is no real solution. If you graph this little guy, he would not cross the x-axis. Look at example 2. This is on the next page in your textbook. This time they gave it to you, looks sort of like vertex form. So I have an x minus 1 squared equal to 25. I'm taking the square root of both sides. Whatever I have that's underneath that radical, when I take the square underneath the square line, is going to be x minus 1. So I don't have to worry, whatever is here, when I take the square root, is going to be whatever was in those parentheses. So x minus 1 on this side, plus or minus 5. I've got two cases. That means x minus 1 could be positive 5, in which case x would be negative, or x minus 1 could be negative 5. If it's positive 5, then x equals 6. If it was negative 5, then x equals negative 4. So two solutions. Look at monitoring progress. This is sort of in the middle of page 499. I'm not taking, you could pause here and do it, check your answers. But again, I'm isolating, finding out that x squared was 25 for the first one. So x was plus or minus 5 when we solved that. If I'm looking at the second one, again, you're isolating that x squared term and just put it on one side, everything else on the other side. When you do that, x squared is negative 2. Anytime I have a square, I'm trying to take the square root of a negative number, I know that doesn't work, and so no real solution. For monitoring progress number 3, 4x squared minus 15 equals negative 15. So 4x squared equals 0. When I take the square root of both sides, x equals 0, so this is another case where I just had one answer. If I go back and look at number 4, that was another one where I have something in parentheses that was being squared. So when I take the square root of both sides, x plus 7 in this case is square root of 0, which is 0. And that means x is negative 7. And I just have one solution for this kind of a problem. For number 5, same principle. I'm isolating that square term. So I'm dividing by 4. I'm not worried because it'll all work out. So x minus 3 squared equals 9/4. I'm taking the square root of both sides. Remember, that's like taking the square root of 9 divided by the square root of 4. So that's the square root of 9/4 is going to be plus or minus 3/2. And so x equals 3 plus or minus 3/2. If x equals 3 plus 3/2, then it's x equals 9/2. If x equals 3 minus 3/2, then x equals 3/2. And for the last one, 2x plus 1 squared equals 36. Again, I'm taking the square root of both sides, so 2x plus 1 equals plus or minus 6. That means 2x plus 1 might be positive 6, or 2x plus 1 might be negative 6. If it was positive 6, I'm going to solve and find out that x is 5/2. If it was negative 6, you're solving and finding out that x is negative 7/2. Let me pause this while we go on for the rest so that you don't have to wait while I do the notes and set up the picking back up with example 3, where we're approximating square roots. We solve it just the way we had been doing. So we're isolating that x squared term, putting everything on the other side, solving for x. plus or minus the square root of 7. It doesn't have a perfect square. So in our calculator, we do square root of 7, take in this case, the 2 digits to the nearest hundredth, I guess they asked. 2 decimal places is what we often do. And find out that that's approximately plus or minus 2.65. Monitoring progress, you're going to be doing the same thing, solving the way you did, and when you get that radical, the square root, let your calculator do the approximation for you. So for number 7, pause here and do it. You should have ended up with plus or minus 3.32. So remember, plus or minus means you're getting 2 answers. X equals 3 and 32 hundredths, and x equals negative 3 and 32 hundredths. For number 8, x was plus or minus 0.63, so 63 hundredths. And x for number 9, x was plus or minus 3 and 37 hundredths. So 2 answers in each case. Turn the page in your textbook and go look at example 4. It's a word problem. They give you the formula, so it's not quite so bad. So volume, remember, for a right solid is length, or rectangular. Right solid is length times width times height. So they told you that the length was 3 times the width. So that means my formula, just in general terms, was 3 times the width, so that was the length, times the width, and the height they told us was 3. Plugging in the numbers that we know, 270 cubic inches was the volume, and that's when on this side, when I do that work, I find out that's 9w squared. I'm going to solve for w squared and find out that was plus or minus the square root of 30. Plus or minus mathematically, but in the context of a word problem, can I have negative widths or lengths? No, I cannot. And therefore, I'm only going to use the positive value and find out that the width was approximately 5.5 feet. 3 times that is 16.4 feet. And so the width and the length that we were asked to find is right there. Looking at example 5 was another word problem, and again, they gave you the formulas. The surface area for this traffic sign was equal to the square root of 3 divided by 4 times the side length squared. So they suggested when it looks like this, to isolate it means you're solving for the s squared term. So I'm multiplying by the reciprocal to isolate that s squared. So 4 root 3 makes on this side s squared, and over here, when I multiply a by 4 divided by the square root of 3, I end up with 4 times a over the square root of 3. Plus or minus, remember if I'm looking for a side length, I'm not going to use the negative root, so it's the positive square root of 4a divided by the square root of 3. We will learn in Algebra 2 how to simplify this expression, but for now, thank goodness for calculators, we'll let our calculator do it for us. So at this point, we're going to plug in the numbers that we know. The area was 390 square inches, and so I'm just doing, in my calculator, I have second square root, 4 parentheses 390 divided by square root of 3. Make sure you're closing your parentheses. Up to look like 1560 divided by the square root of 3, and that's approximately 30. Monitoring progress on page 500. When you work those out exactly like the example that we did for number 4, this width should have been 5.9 feet, and that length should be 17.7 feet. For number 11, the formula was different than the one they gave you. So they told you the surface area of the sphere was 4 pi r squared, which we should already know that, but if you don't, here it was. And so you're solving for r squared, so you're going to be dividing both sides by 4 pi. So I have s divided by 4 pi equals r squared. You're taking that square root of both sides, so I have the square root of s divided by 4 pi. At that point, plug in what you know. So as they told you, that surface area was 804 square inches and divided by 4 pi. And when I let my calculator do that work for me, I end up with 8 inches. The monitoring, that was the monitoring progress. That concludes 9.3. And I don't have worksheets for this, so for these, we'll be doing the exercises and I will post those on my school app. And we're getting near the end of what we can do, I think. I'll talk to you later. Bye-bye.